Now, what is a green roof? A green roof, or a living roof, is a rooftop that's covered with a waterproof membrane, planting substrate, and vegetation. Green roofs can be used to produce fruits and vegetables or create a visually pleasing roofscape that provides many benefits. Green roofs take an otherwise neglected space and turn it into something that's aesthetically pleasing and beneficial to both the people and the surrounding environment. There are two types of green roofs, intensive and extensive. Intensive roofs are heavier and require more maintenance. An intensive roof can support trees, walkways, and benches, which provides a more interactive landscape that serves as a rooftop park or garden. Extensive rooftops are typically much lighter and consist of strong native plants. An extensive rooftop's sole purpose is to provide environmental benefits and is not typically accessible as a park or a garden. So who has to do it and why should we implement it? Well, the Denver Green Roof Initiative aims to change legislation requiring all buildings over 25,000 square feet to turn a percentage of the rooftop green. These installations can be pretty pricey, costing upwards to $125,000, and typically need to be done by professionals. However, a typical roof needs replacement every 10 to 15 years, so building owners will only need to make these changes at the time of replacement. On top of that, a standard green roof can last as long as 4 times longer than a normal roof, so in the long run, these roofs are much more cost effective. Green roofs also mitigate runoff, lowering the need for expensive sewage systems, and the greenery acts as natural insulation, lowering the cost of indoor cooling systems and fighting the urban heat island effect.
Installing a green roof can help you reduce wastewater treatment costs in the areas with combined sewers, reducing the volume of runoff and slowing its flow, thereby reducing the frequency of CSO events. Here are some benefits of the Green Roof Initiative. Reducing the rate at which water flows from the roof into the sewer system, increasing the amount of water that remains on a roof after a storm. Green roofs retain the most water in summer months when the plants are active and warm. Weather boosts evaporation. Green roofs are recognized for their ability to mimic natural hydrological processes as part of the watershed. Green roofs reduce the volume of stormwater flowing from a roof and therefore the ability of stormwater to convey pollutants to water bodies. Green roofs offer economic, environmental, and societal benefits. For the individual building in the water-urban environment, these benefits range from stormwater management impacts on local infrastructure to amenity benefits for building occupants for the community.
This slide shows the total 15-year investment and cumulative benefits for the 57 million square feet of building space that's going to be covered by the Green Roof Initiative. According to the Green Infrastructure Foundation, an investment of about $1.396 billion will result in a cumulative public and private benefit savings of about $1.441 billion, and that's after 15 years. Therefore, the cumulative benefit at the 15-year mark will be around $45 million. In this next slide, it shows the initial costs and the 15-year benefits. As you can see in this slide, the initial cost is quite high at about $21 per square feet. So while the cumulative benefits at 15 years will mean an extra $45 million for the local economy, there is a hefty upfront cost burden. Also, an increase of almost $22 per square feet on real estate is a good thing for landlords, but that increase in rent will potentially exacerbate ongoing gentrification of the local community. The initial installation and maintenance costs are prohibitive, and as we will see in the next few slides, the majority of these initial costs will be paid for by already socioeconomically disadvantaged communities. Here we have a QGIS map we made with building shapefile data from denver.gov. It also contains low-income area shapefile data from the Department of Housing and Urban Development, as well as demographic data from the U.S. Census Bureau website. The map displays buildings with more than 25,000 square feet, excluding residential buildings under 50 feet in height, are displayed in black, and socioeconomic data is overlaid to show us the most at-risk communities in darker red and orange colors. Doing this allows us to visualize the area that will incur the majority of the costs for installation and maintenance on the green roofs, as well as the socioeconomic information for that particular area. What this map shows us is that the communities who are most impacted by the installation and maintenance costs for these green roofs are those communities that are the least able to afford it. This next map shows the same socioeconomic data as the previous slide. In this slide, however, the socioeconomic data is overlaid on only those buildings that are designated as housing by the City of Denver while still meeting the requirements set forth by the Green Roof Initiative, meaning they are more than 25,000 square feet and greater than 50 feet in height. We can see that the areas most affected by this increase in housing costs are the areas that are least able to afford it. And this increase in monthly housing rental cost exacerbates income inequality and accelerates gentrification in areas that are already experiencing an unprecedented rate of gentrification. So, while there are many positive benefits to the Green Roof Initiative, it's important to realize that there are negative implications to this as well.
Green roofs applied in class themes. The social construct of nature is the way we perceive our environment and nature, and is learned or inherited. If we remember the nature-human spectrum from earlier in class, I think we can agree that no matter how you define environment, green roofs are both human and natural, bringing flora and fauna to inhabit man-made environments. This creates a new idea of environment, whose meanings and benefits will be transferred to future generations, thus perpetuating the cycle and knowledge that is our social construct of nature. If it is what we are born to learn and know, it will be continued on so long as it benefits society. In regards to energy and energy use, green roofs don't have to be completely covered in just plants. It can be a combination of plants and renewables as well. As previously discussed, there is a massive amount of energy saved from cooling and maintenance costs, and green roofs provide ample space to install solar panels or small-scale wind turbines, as well as bringing carbon-sequestering plants into areas of higher carbon output. When it comes to food and water, there are many benefits as well. Because there can be a mixed use on these new green roofs, it opens up the door to potentially use the space for small-scale urban farms. For example, large-size apartment complexes can give space to tenants to grow their own food. Local restaurants can rent space on top of green roof buildings to grow produce for their menus, or schools can grow food for lunches for their students and teach their pupils sustainable living practices. In terms of urban sustainability, we believe that sustainability is loosely defined as something being able to maintain and provide for itself. Green roofs last 4 times longer than traditional roofs, can provide space for agriculture and better the immediate environment around it, both human and natural. In relation to climate change, they can help cool buildings, which reduces the use of refrigerants, sequester carbon through plants, and cools surrounding environment by reducing the urban island effect. There are countless other advantages associated with the green roofs that help combat the effects of climate change on a local level. So as you can see, green roofs have a big impact on our environment, society, and sustainability.